Today's topic: characteristics feature of psi, psi square and energy of the particle in one-dimensional box. Today we will discuss the characteristics feature of psi, psi square and energy of particle in one-dimensional box. First of all, the wave function for a particle in one-dimensional box is given by psi is equal to root 12 sine n pi x by L. This expression is already done in previous class. The maximum magnitude of sine n pi x by L is 1. Therefore, the maximum magnitude of psi is root 2 by L. Now the psi may be positive or negative. It may depend on the nature of n and x, but the magnitude of psi square is always positive and the maximum magnitude of psi square is 2 by L. To get the maximum magnitude of psi and psi square, the sine n pi x L equal to 1. Here n pi x L or sine n pi x by L is equal to 1. That means sine j pi by 2 where j is equal to 1357. Now the n pi x by L equal to j pi by 2. Now the x is equal to jl by 2n. Okay, when we already known particle in one-dimensional box, the region between in x-axis, along x-axis, the region between 0 to L where the particle is moving. So the value of x in between the range of 0 to L, and this diagram we have seen that the range in between 0 to L. Now x is equal to jl by 2n. Now putting the value of n is equal to 1, in previous class we already discussed the permitted value n is equal to 0 but not acceptable. So the minimum value of n equal to 1. In previous class we already discussed. Now when n is equal to 1, that is putting the n is equal to 1, that is x is equal to jl by 2. Okay. Here putting the value of j is equal to 1, this expression, now x becomes equal to L by 2. Okay. Now putting the value of j equal to 3 in this expression, then the value of x is equal to 3L by 2, because 3 into L by 2, that is 3L by 2. This value L is equal to 3L by 2, it is not acceptable. This value is not acceptable. Why this value is not acceptable? Why this value is not acceptable? We already know that the particle is moving along x-axis in the region between 0 to L, but here the value of x is equal to 3L by 2. That is, this value is greater than the region between 0 to L. Here the region is 0 to L, but the value is 3L by 2. That is, this value is greater than that of 0 to L. That is x equal to L. That is, the value is greater. So this value is not acceptable, because we are known that the particle are moving along x-axis in the region 0 to L. This value is 3L by 2. It is more greater than x equal to L, and that's why not acceptable. When n is equal to 2, that x is equal to jl by 2 into 2, that is jl by 4. Now putting the value of 1357, this expression x is equal to L by 4, this value is acceptable because this value lies in the range between 0 to L. And this is 3L by 4, this is also acceptable because this value lies in between the range of 0 to L. But 5L by 4, this is not acceptable because this value does not lie in the range in between 0 to L. Now putting the value of n is equal to 3, then x is equal to jl by 2 into n, that is 2 into 3, that is 6. Now putting the value of 1357, the x is equal to L by 6, L by 2, 5L by 6. These values are acceptable, but 7L by 6 not acceptable because this value does not lie in the region between 0 and L. Now we have understand the plot psi versus x. This is the particle in one-dimensional box. This is the plot of particle in one-dimensional box. In this plot, we have plotting psi against x. The psi versus x, the wave function of the particle versus x. X is equal to box length. The particle is moving along the x-axis in between the region 0 to L. From the plot, we have seen that the wave function vanishes at the boundaries. From n is equal to 1, the wave function vanishes at the boundaries. That means the wave function vanishes this point, that is x equal to 0 point and x is equal to L point. The wave function vanishes means in this point there is no probability of finding the particle. There is no probability of finding the particle at the point x equal to 0 point and x equal to L point. That is the boundaries. And the maximum probability of finding the electron at the point of L by 2. Maximum probability kothay? Maximum probability of finding the particle is L by 2. It is important to note that for the quantum number n value, there is n minus 1 node. It is important to note that for quantum number n value, the node is n minus 1 value. That is, the question is arise, what is the number of node at the point of quantum number n is equal to 1 value? Here the number of node equal to 0, because we have known that for quantum number n value the node is n minus 1. So number of nodes in this point equal to 0. Now the question is arise, what is node? The node is the point where the probability of finding the electron density is 0. Okay. Now at the quantum number n is equal to 1, the wave function vanishes x equal to 0 and x equal to L. That is at the boundaries. The probability of finding the electron is 0 at the point of x equal to 0 and x equal to L. And the probability of finding the electron density is maximum at the L by 2 point. Now we will discuss the curve at the value of n is equal to 2. N is equal to 2 quantum number. N is equal to 2 quantum number. For n is equal to 2, we have seen that the psi 2 wave function vanishes at x equal to 0 point, at x equal to L point and L by 2 point. For n is equal to 2, I repeat again, the wave function vanishes x equal to 0, x equal to L and L by 2 point. And the probability of finding the electron density is maximum. The probability of finding the electron density is maximum at the point of L by 4 and at the point of 3L by 4. At the point of, very interesting, at the point of L by 4 and at the point of 3L by 4. It indicates that the particle can travel from one side to another side without crossing the middle point of the axis. It can be rationalized if it is assumed that the particle behaves as a wave over the entire place. If the particle considered as a particle, then it would be not possible. And for n is equal to 2, the node is generated at the point of L by 2. That means at this point the electron density is maximum. Electron density is 0. Now the question is arise, the electron can travel from one side to another side without crossing the middle point? How it is possible? It can be possible if the nature of the electron acts as a wave enters the whole phase. If the electron acts as a particle, it would be not possible. Okay? For n is equal to 3, the wave function psi 3 is vanishes at x equal to 0, at x is equal to 0 and x equal to L point, that is the boundaries, and also vanishes to internal node point, that is this internal node point and this internal node point, and this point the wave function of the electron is 0, that is node is generated. So from this plot we have seen that the wave of the electron here is the positive direction and it is a negative direction, and that's why we already discussed that psi may be positive or negative. But from this plot we have seen that where psi square against x, we have seen that the peak of the wave function for n is equal to 1, n is equal to 2 and n is equal to 3 is always positive, because from this expression the psi square always positive. Now we will discuss the nature of wave function and energy depending on the n value. The nature of wave function. The nature of wave function and energy depending on the value of n. Like it is evident that with the increase of n, the number of nodes increases and the wavelength decreases, and the corresponding increase of the total energy, and which is equal to the kinetic energy in nature. And nextly we will discuss the wavelength of the wave function. The wavelength of the wave function. The wave function is to be 0 at the walls, that is at the walls the wave function will be 0. The length of the box must be integral multiple of half wavelength, that is L equal to n lambda by 2. Now how it can be proved? N is equal to n lambda by 2. We know that the kinetic energy E is equal to half of mv square, and from half of mv square we have seen that in previous class E is equal to p square by 2n. Now p is equal to h by lambda. Putting the value of h by lambda, then the equation becomes h square by 2m lambda square. This is the number of equation 1. And next we know that the energy is given by n square h square by 8 square, now the 2. Now comparing equation 1 and 2, we have proved that L equal to n lambda by 2. Next we'll start the symmetric and anti-symmetric wave function. Symmetric and anti-symmetric wave function. Based on the symmetry of the function with respect to the midpoint, of the box, the wave function can be classified as symmetric wave function or even function having a center of symmetry, and anti-symmetric or odd function having no center of symmetry. From this figure, we have seen that for n is equal to 1, this state is psi 1, and psi 1, the with respect to midpoint, the psi 1 is a symmetric wave function, because this point and this point is very similar. With respect to midpoint, the psi 1 is a symmetric wave function. The psi 2 with respect to midpoint is the anti-symmetric wave function, because the peak is upward and the peak is downward, and so this is the antisymmetric wave function, and similarly the psi 3 is for n is equal to 3, the according at the midpoint, with respect to midpoint, the wave function is the symmetric wave function, that is the psi 1 psi 3 the symmetric wave function, and psi 2 and psi 4 is the antisymmetric wave function. Okay, in next class we will discuss the application of the particle in one-dimensional box. Thank you.